we have to solve this equation. 1 plus sine of x plus sine squared of x plus sine cubed of x plus sine to the fourth of x and on and on and on equals 2. So basically it goes sine from the 0th power of x all the way to sine of the infinite power of x. So at first you might think that we have to do some crazy simplification on the left-hand side using some really vague trigonometric identities or equations, but actually you might notice that this whole left-hand side is just a simple geometric series. And the reason that is because you have your starting term 1, or you can even call that as sine to the power of 0 of x, and then with each term you're just multiplying sine of x. So to get from here to here, you multiply by sine of x. To get from here to here, you multiply by sine of x, and so on and so forth until infinity. So we can rewrite this left-hand side using the equation that you might know, a over 1 minus r. Now what that means is a is the first term in the series. In this case, that is 1. And r is the common ratio between the terms. And in this case, as we said before, it's sine of x. So we can rewrite the whole left-hand side as 1, because that's our first term, over 1 minus sine of x, like that. And the 2 is still the same. The right-hand side is still the same. So now let's just solve for sine of x. Let's multiply both sides by 1 minus sine of x. And we get 1 equals 2 times 1 minus sine of x. And then let's see, divide by 2 on both sides, and then add sign, and then subtract 1, and then multiply everything by -1, and then you'll get sine of x equals 1/2. So there we go. But we still need to solve for x, not sine of x. So how do we solve for x in this case? Well, you might know by your trigonometric common values that the sine of 30 degrees is equal to 1/2. Now, why is that? If you look at the unit circle, if you might recall, the unit circle is basically a circle of radius 1 that gives you your sine and cosine values. If we go up 30 degrees over here, then we see the point over here is the square root of 3 over 2, 1/2. Square root of 3 over 2 is the x value, 1/2 is the y value, and the y value for the unit circle is always the sine value. So that means sine of 30 degrees is 1/2. And let's convert this into radians. So to convert 30 degrees into radians, what you do is that you take 30 and then you multiply by pi over 180. That's what you do. And so if you do some simplification, you get pi over 6. Pi over 6 and 30 degrees are the same when you compare radians and degrees. However, pi over 6 isn't the only solution. You can also go around the whole unit circle once, in this case 2 pi. Normally I would say a whole 360 degrees around, but if you convert 360 degrees to radians, you get 2 pi, because 360 times pi over 180, 360, 180, that's just 2, so 2 times pi. So we can also say that there are actually an infinite number of solutions here for sine of x equals 1/2, because we can say one of those solutions is pi over 6, but we can also add or subtract 2 pi around, and we can do that as many times as we want. K. And this k here is basically any integer. So this k is any integer. It can be -5, 5, 10, 20, it doesn't matter. As long as it's an integer, this basically means going around counterclockwise or clockwise around the circle. So this is our solution over here. However, there is one more solution that we want to make sure we don't miss out on. It's that another answer to sine of x equals 1/2 is 5 pi over 6. Now, why is that? Keep in mind, there's also, in this unit circle, there's another way you can get a y value of 1/2. That's if you go all the way over here. I'll dot that in right now, right here. It will have a different x value. In fact, it will be negative square root of 3 over 2. However, it will still have the y value we want, which is 1/2. So what's this angle measure then? Well, we want to measure from here all the way to here, and that angle measure is 150. And you can see that by some symmetry. If we just start over here and go up, then that will be 30 degrees, since over here and up, it will be 30 degrees as well. So we can say that this whole angle over here, I won't draw it, but I won't draw like the angle symbol, but it's 150 degrees. This right here. And let's convert that into radians. 150 times pi over 180. Let's see, the zeros cancel out. 15 divided by 18 is the same thing as 5 divided by 6. And so that is 5 pi over 6. And once again, same as over here, we can go around the circle as many times as we want and you still get a different answer. So we can add 2 pi, and instead of k, let's just use n as another variable, just so we don't use the same variable for all n that are integers. So there we have it. These are the two solutions. Actually, sorry, I shouldn't say two solutions. These are the infinite number of solutions for this equation right here. Pi over 6 plus 2 pi k for all integers k, and 5 pi over 6 plus 2 pi n for all integers n. And we are done.